Alright, today we are going to do section 1.4 and today we're going to be introducing the basics of polygons. And you should be no stranger to polygons. Polygons are just any sort of shape drawn about. They can be moved around, morphed, all different sorts of shapes as long as they connect all four sides. So this shape we just drew right here is a polygon. And a polygon has some special characteristics. First off, we name polygons by the number of sides starting at 3 moving downwards. You can't draw a polygon with 1 or 2 sides. Notice this one here on the right has 5 sides. And we just keep on going to nth sides. So there's an infinite amount of sides we can put on polygons. The more sides you add, the more it starts to look like a circle, or at least if you're talking about regular polygons. Now each polygon has a name associated with it. 3 sides is a triangle, 4 sides is a quadrilateral, 5 is a pentagon, 6 is a hexagon, 7 heptagon, so on and so forth. And you may be familiar with like an octagon, quadrilateral, triangle already. Those are pretty familiar shapes. But if you don't know what to call it, you just count the number of sides and call it an n-gon. So this polygon right here has 1, 2, 3, 4, 5 sides. So a 5-sided figure can be either called a pentagon, which is its formal name, or you can call it a fivegon, which is its informal name. Now, you might be working with multiple polygons at one time, so it would be nice to label it. So we can label this guy A, B, C, D, and E. And conventionally, you label clockwise around the polygon. And so this side right here that I'm going to highlight in green, this would be side BC. So if you want to reference a certain side of a polygon, you call it the segment that is that side. And then where two sides meet, we form what is called a vertex. So this spot right here, that point, would be vertex D. All right, and we would also call this guy polygon A, B, C, D, and E. So polygon A, B, C, D, E is a 5-sided figure, and that could be either called a pentagon or a fivegon. And we label it clockwise, and we reference the side and vertex accordingly. Now, polygons can be drawn in two different ways. They can be all pointing outward, so we could have something like, I don't know, like this rectangle here. So it's all pointing out. I'm going to draw a little bit more of a funky shape. There we go. I like this guy. So we could have something that all the verti are vertexes are all pointing out. Or we can have a figure where we have a little bit of a concave. There we go. So if you have this little cave, imagine it like a little mouth. That would be a concave figure. And I like to remember that because these concave figures cave in on themselves. So this guy would be concave, and this other guy would be convex. And so it's not too difficult now. If I were to give you a couple of shapes, A and B, you would be able to tell me what the shape was based off the number of sides and, well, if it's convex or concave. So that's going to be our first shape right here, shape A. Our second shape is going to look like so. Oops, that did not work. So our second shape is going to look like so. So let's first count the number of sides. So we have 1, 2, 3, 4 sides. If we scroll back up to our chart, a 4-sided figure is a quadrilateral. So this would be a quadrilateral. And it does have a mouth right here where it caves in on itself. So this would be a concave quadrilateral. Next, let's count the number of sides on this next polygon. So we have 1, 2, 3, 4, 5, and 6. So this would be a hexagon. And notice that every vertex is moving outward. It does not cave in on itself. So this would be a convex hexagon. And while all polygons have their importance, we are going to focus primarily today on triangles and rectangles. And as a quick reminder, you can find a perimeter and the area of both of those quite easily. So if we draw a triangle here, oops. So here's our triangle. This triangle is going to have sides A, B, and C. That's another way we can label polygons. And it is also going to have a height associated, which is going to be perpendicular to the base B, and it's going to have some height H. And the perimeter, which we're going to label as P, is the distance when you add all three sides together. So that's going to be A plus B plus C. And the area is going to be 1/2 the base B times the height H. Next, why don't we do the area and perimeter for a square. So here is our square, and the square has one side, S, because what's nice about a square is that all four sides of the square are congruent, and they all have congruent 90-degree angles. Squares are special. So the perimeter would be equal to S plus S plus S plus S, or 4S. And the area would be equal to S multiplied by S, or S squared. So we can go ahead and move our square up just a little bit so we can fit in the rectangle. And our rectangle is like taking our square but elongating two of the sides. So we have a width of our rectangle and the length of our rectangle. All the angles are still going to be 90 degrees. And opposite sides are congruent. And so the perimeter of a rectangle would be equal to L plus W plus L plus W, or 2L plus 2W. And the area is going to be equal to the length times the width, so L multiplied by W. And the reason why I'm reminding you of this is because I want to take these polygons and translate them into the coordinate plane, and then find the perimeter and the area using the distance formula to find these special properties of these figures. So let's find the perimeter of triangle ABC. And the examples I'm going to be doing today are all going to be triangles, because squares and rectangles are quite easy because you can count the number of sides that they take up because they are straight in the coordinate plane. There's no diagonal lines, right? So all the examples today are going to be using triangles, but the same properties apply to squares and rectangles. So we're going to have point A over here at -2, +3. And point B is going to be down here at -2, -3. And we can connect that. So that's side AB. And next, we're going to have C all the way over here at the point 3, -3. All right, and I know that's a little off, and then AC is going to connect right here. And so we want to find the perimeter of this figure. And remember, the perimeter is all three sides added together. So two of the sides are going to be really straightforward to find, right? So first, let's find the length of side AB. So we can, one, count our squares. So 1, 2, 3, 4, 5, 6. That is one option. Or we can subtract our y exponents. So we could take the absolute value of 3 minus a negative 3, and that is going to be equal to a positive 6. So let's not lose this value of 6. Next, we need to find the length of BC. So that is going to be the change in the x values, so we can count those squares, 1, 2, 3, 4, and 5. Or we can just subtract our x values. So that is going to be a negative 2 minus 3 absolute value, which is the absolute value of a negative 5, which equals a positive 5. Let's also not lose that value. And then finally, we need to find the length of AC, which is going to be a little bit tricky because we need to use the distance formula. And remember, the distance formula is as follows. AC is going to be equal to x2 minus x1 squared plus y2 minus y1 squared. And so we need to go over here to our triangle and label an x1 and an x2 and a y1 and a y2. Let's, for simplicity's sake, make our top value x1, y1, and our bottom one x2, y2. So AC is going to be equal to the big old square root of x2, which is 3, minus x1, which is a negative 2, and we're going to square that quantity. And then y2 is going to be a negative 3, and we are going to subtract from that a y1, which is a positive 3, and also square that value. And so this is going to simplify into 3 minus a negative 2 is a 5. 5 squared is 25, plus negative 3 minus 3 is going to be a negative 6. Negative 6 squared is a positive 36. And if you add those together, and take the square root, that is approximately going to equal 7.81. So now we have all three side lengths. That's the pertinent information that we need. So all we need to do now is to find our perimeter is add up our three values in these square boxes. There's a little button down here to go down a page, and I keep on hitting it. That's why that's happening. So let's do 6 plus 5 plus 7.81, and that is going to equal 18.81 for the perimeter. All right. Next, why don't we apply the same sort of principle into finding the area? And instead, this time, it's going to be triangle DEF. And so here is our coordinate plane. And the first thing we need to do is actually plot this triangle. So point F is going to be all the way over here at negative 4, negative 3. Plot E is going to be at a positive 4, positive 3. And that is not straight across. Sometimes I like to cheat and draw my line like this and then go like that. There we go. So E is going to be at positive 4, negative 3. And then point D is going to be all the way up here at 1, 3. And so we need to connect both of those together. All right, so the first thing we need to do is find the base, the length of our base. Because remember, the formula for area is equal to 1/2 base times the height. So let's first find the base. And the base of the triangle is quite easy to identify. It's going to be this green highlighted segment below. And so all we need to do is find the length of FE. You can count your squares, or you can take the absolute value of a negative 4 minus 4, which would equal, of course, a negative 8, which equals a positive 8.
Next, step number 2, we need to find the height of the triangle. And to do that might be a little bit more complicated, but imagine drawing down a dotted line here, and it's going to intersect right there, right? Perpendicularly. So that intersected point is now +1, -3. So our height, h, is going to be equal to the absolute value of a 3 minus a -3, which is of course equal to a +6. And the absolute value of a +6 is 6. And then finally, we're going to plug into the formula for area. So we have 1/2 base times height, which is going to be 8 times a 6. And that is going to equal 24, and then units squared, whatever our units is. All right, so that's all I have for today. It was the introduction of polygons, and then we also found the area and perimeter of polygons, and just did some nomenclature stuff. Remember convex and concave. If you have any questions, please let me know.